Good afternoon, everyone. Welcome to the session on tips and tricks to help your IoT architecture scale. So a lot of times when we talk about IoT, we talk about, little Raspberry Pis connecting to sensors, measuring the temperature in your house, or perhaps monitoring whether or not a door is open or closed. And what this session is going to cover is a general framework for how to think about IoT applications when we start talking about them at a serious commercial level scale, when we're talking about deploying IoT solutions to benefit our companies, our production lines, smart cities, kind of the very large scale, millions of devices of IoT. So if there's one thing I've learned about working in IoT for the last 2.5 years is to always define my terms, because every single term in IoT is overloaded, which makes it a fun area to work in. But really what makes something IoT is it has to have all 4 of these ingredients. It wouldn't be the Internet of Things without the things that you're measuring. So you have your devices, your things, your objects, your whatever that you're interested in monitoring in order to gain some sort of insights about the world around those things. And it's called the Internet of Things, not the local on-premise network of things, because all these things have some aspect of connectivity. So they're all connected via some IP-capable way to the back-end internet cloud. This could be directly via IP, it could be via cellular connection, it could be via an external gateway because the local thing you're talking about is an old PLC that speaks Modbus. All of those scenarios are IoT. Now you've got your things connected to the internet, and what are they doing? They're sending data up to the internet, so you've got to measure what this is going on, and that data is then processed via some form of analytics that's specific to the business application that you're running on your IoT solution. So if you're managing a fleet of vehicles, you care about things like emissions, whether or not that driver has been on the road for the right amount of time or too long of a time, whether or not the trailer's cooling properly. If it's a smart city, you care about things like traffic. If it's a manufacturing plant, you care about efficiency, et cetera, et cetera. The analytics part depends specifically on your given application, so I'm going to just kind of bubble it all up into one thing. So these 4 things make up IoT. It's all pretty easy, but I'm going to simplify it even further by saying that IoT is simply harnessing signals from remote devices to either improve existing businesses or to start new businesses, though the harnessing part is tricky, especially when scaling up. And it's really that last line that I'm going to focus on for the rest of the talk, because you can read about getting started with a Raspberry Pi or whatever anywhere, but really scale is what's going to make you or break you when you're creating an IoT application. So to talk about scale, I want to put in this framework of to think big and to start small. This is how you can think about approaching some of these monolithic IoT applications that can seem overwhelming with the number of independent variables and sheer number of choices that you have to make. Because ultimately what it comes down to is that you have a set of business objectives that are driving why you're making a solution in the first place. You know that solution has to scale because you're dealing with a large number of things, but you're probably going to start off with a very small proof of concept. And you're going to do something with the data that you're getting, and that something with the data might change as you analyze the data over time and get more and more insights. And all of those things put together make up your IoT architecture. And really, when we talk about architecture, there are 2 main parts of the architecture. There's the architecture that's required for your data processing, and then there's the aspect of that architecture that allows you to scale up when you go from 1 or 2 or 3 or 5 or 10 devices all the way up to 1 or 2 or 3 or 5 or 10 million devices connected in the same application. And what's driving both that infrastructure with the scaling infrastructure and the data infrastructure, underlying both of those and influencing both of those are the distinct business objectives that are causing you to build this application in the first place. And I do understand that oftentimes these business applications, especially in large companies, can come from multiple different business units that sometimes might not be speaking to one another, and I'm sure no one in the room has ever hit anything like that. So when you consider what you're trying to accomplish, just let that be the driving force behind what it is you're building. And keep in mind always what that question is of what exactly are we trying to do here? Because oftentimes it's not we're trying to connect millions of devices. Why are you trying to connect millions of devices? Okay, well, we're trying to optimize our production processing. Why are we trying to optimize our production processing? It's because we think that we can do better, or we want to know what's going on in our infrastructure. So just keep in mind always what that business problem is, and ask yourself as you go throughout building your IoT application, how you're tracking towards that goal. Or is there additional information that you need in order to track this? Or is there some aspect of the architecture that has impacts on the business later down the road that you then need to take up to the business decision maker and say, hey, there are two ways we can go here. Which way would be the biggest impact to our company? So just keep in mind that the business is driving a lot of the tech here. And so for the rest of the talk, I will be talking more about the commercial IoT. It's not that consumer IoT isn't interesting, it's just that it doesn't present a lot of the scale issues and the scale problems that commercial IoT really has, and where using the cloud really shines is when you start to hit that very large scale, because it abstracts away a lot of the problems that typically you can learn to deal with if you're dealing with, a very small group of devices, but when you really start to scale up, that's where you want to have automation and cloud scale support. So to start it off, I want to talk about IoT architecture as a whole. And again, there are three bits of IoT architecture. The devices that are all sending your data. There's some cloud gateway that the devices are all sending their data to the single point in the cloud, and then the backend architecture, backend processing is all reading from this single cloud entryway. And this cloud gateways themselves are often built to support IoT type of scale. If you're using Azure IoT, IoT Hub is the service here that you'll use, and IoT Hub in particular has been built to support simultaneous connections of millions of devices simultaneously in a single IoT Hub. And there are other patterns you can use if you need to have geo-sharding, or if you need even larger scale. We load test a lot in Azure IoT. So these are some of the components you have. And again, as I mentioned earlier, the backend processing can be responsible for any number of things, from running your machine learning algorithms to just cold storage to on-the-fly hot path analytics, making sure that certain levels of telemetry are where we want them to be, to the dashboards that's showing the telemetry, to the hookups to the ERP systems that you're using to track requests for servicing, and it goes on and on. So anything that is not device itself happens typically in the backend processing. Now, when we talk about the cloud architecture, I've got a bunch of tips and tricks that I've collected over the years that I want to share with you all to hopefully avoid some of the issues that I've seen in the past. And first and foremost is to beware of bottlenecks. Each service that you're going to be using in the cloud has been built with different usage patterns in mind. So just be aware of this when you're planning your solution, and be aware of what exactly you need to have when you're constructing your architecture. So know kind of how each one has been set up, and whether or not you're going to be overwhelming one service because you're sending an unfiltered data flow through and you don't realize that you're going to kind of push it over, especially if that particular service is meant to do a lot of processing on individual data packets. Now, we all know that as much as we plan, things will always go wrong, so make sure you account for that when you're building. So know what to do when things go wrong. Make sure that your devices have a retry policy in place in case connectivity is spotty. So devices can batch up messages, retry. Do exponential backoff is a really good way of making sure that devices will continue to send data without having to deal with a lot of the problems of just kind of retry. Exponential backoff will allow the device to keep sending its data, but give the backend time to actually process and catch up, because that's due to back pressure in whatever your data processing pipeline is. So have your devices use retry policies, ideally with exponential backoff, and make sure that you're using with your messaging architecture, especially with your kind of communicating within different subservices within your cloud, your backend business analytics, to use services with an at least once delivery mechanism. That way you know that you're not actually losing data packets because that something got handed off and then kind of dropped because whoever was supposed to be receiving that information didn't actually receive it and you didn't get an ACK from that. It's also nice to know the health of your services. So just have a way of keeping track of what's really going on with all the different services you're using. If you're using Azure, we have Azure monitoring services for most of Azure, if not all, which will allow you to do this really easily from within a single kind of a single pane of glass, so to speak. So you can have both metrics that tell you what are the numbers involved, how many messages are being sent overall, how many devices do I have, but also logging of what is happening at a given moment. Am I getting throttled in this one service? Are we experiencing an outage? What is going on? And kind of give you a holistic view overall of your IoT solution. And then last, if you're going to be global, be global. And what I mean by this is to know the local data laws of the areas that you're doing business in. So for example, the EU has much, much, much stricter data privacy laws than here in the US. So if you are a global company or if you have aspirations of being a global company, make sure that you are compliant with the data laws in the markets that you want to go to. Azure goes through an extensive compliance audit every year to make sure that all of our services are in line with that. And if you go to the Microsoft Trustworthy Computing site, you can see what the compliance certifications that Azure All Up has if you're planning on Azure. So this was for the cloud architecture, and I do have some tips and tricks for specifically around device architecture as well, because especially if you're a cloud person like I am, you're like, devices are just small databases sending information to me. But actually, if you're a device person, you know that how your devices are set up matters almost as much, if not possibly more, than how your cloud is architected in the back end. Especially if you're shifting from an on-premise solution, like a lot of industrial automation or manufacturing plants have. Make sure you examine your on-premise architecture and make a note of how things are set up today and where your trust boundaries lie. Where are your firewalls involved in this scenario, and what are potential areas of potential exploit if the wrong device is connected to the internet? Just mentioned, know your trust boundaries. Threat models are your friends. I know they're hard and they're painful to go through, but really, one well-done trust model will save you months and months of cleanup work if and when you do get hacked because you left a trust boundary exposed to some malicious actor. So trust boundaries are important, and one way of going around this is using gateways. So gateway devices exist on-premise and are used to connect a lot of devices, kind of like leaf devices or child devices. And gateways can be used for any number of reasons. They could, as I mentioned, be used kind of to proxy through data from devices that are not meant to be ever connected to the public internet. They could also be used to connect on behalf of devices that just don't speak IP. They speak some other protocol that's industry specific, like Modbus or Z-Wave or Zigbee or what have you. So gateways are great for that. They're also great for doing on-premise data collection and kind of going through it and filtering out excess data that you don't really need to have in the data backend. So for example, if you are only interested in a state change of a sensor, like if it goes from on to off or a door is open or closed, you only really care about when that changes, but that sensor itself might be sending like, the door is still open, the door is still open, the door is still open, the door is still open. Your backend doesn't care. The backend only wants to know when the door goes from open to closed. And when you aggregate that at the gateway, you can easily say, the door has been open, but now it is closed, so we're gonna send up a notification to the cloud saying that door is now closed as of, 2:05 p.m. on Thursday, September, the 28th? 28th. So that's it for data architecture. So that's really great, but that also gets into data processing. Data really is the lifeblood of IoT. Any IoT solution is driven by the data that's coming off the devices from the services themselves. And when you consider how you're collecting data, don't just consider like, we have data now. You have to think about how every single piece of data will be stored, extracted, mapped, searched, sorted, and overall computed upon throughout the entire architecture. And know what that means for the rest of your downstream pipeline. Speaking of that pipeline, you'll need to validate that pipeline at some point along the way as you build out your solution, and that's fine. The only problem is that sometimes IoT solutions don't require data to be sent all that frequently. Maybe once a day, once a week, or once a month, depending on what it is that's being examined. So, but in that case, that makes it really, really hard for development, where you don't want to have to come into the office, Thursday at 10 p.m. in order to be online that one time that tricky system you're trying to debug is actually sending data. So what you want to do oftentimes in development is you send data much more frequently. And that's great. Just remember to turn that back down again when you go to actually deploy your solution. Because that can help you save a lot of money on your Azure bill. So again, I've got some tips and tricks around how you manage your data itself. And first and foremost is to challenge your data assumptions. Just think about how you are actually going to be using each piece of data that flows throughout your system. And especially when you're in the proof of concept phase, Don't get ahead of yourself because you're proving out a concept. You are not necessarily trying to build the whole thing from start to finish and kind of come up with the grand scheme of the Sistine Chapel of an IoT solution without ever taking a Drawing 101 class. So think about what exactly do you really want to do? What is the one problem that is driving your architecture? And sit down, map that out, and come up with the minimum set of data that you need to send. And because this is a proof of concept, it's okay to change it later. The reason I like saying this is please don't spam the back end. I've had a lot of customers who tell me about how much data they're going to be sending to the cloud when their services reach full maturity. And I think my favorite has been a customer who, when you take the number of devices times the size of the data packet times the frequency of data that they were going to be sending, it came out to be they were going to be ingesting to the cloud 1 terabyte of data per second. And when my customer and I, or my colleague and I were on the phone with them, we were doing the math in the background as they told us these numbers, and we're like, do you really mean you're going to be sending a terabyte of data? We just want to make sure we're understanding you correctly. And they're like, yes, we will. And really, this again, I go back to the challenge your data assumptions. Are you really going to need every byte of that terabyte of data in the back end? And are you really going to be dealing and managing and actively using this data? Or can you achieve those same business outcomes with far less data? Just try to pare everything down because you can always add later. It's just very, very hard to cut things back at the end. And as I mentioned before with the architecture section, just keep tabs on the health of your services, and that'll let you know when you're making a mistake and spamming the back end, so you can then go and make an update to no longer spam the back end. Even if you're sending the right amount of data, sometimes you just need to reconfigure the services to tell the service, you should be expecting more, or maybe I need to use a slightly larger VM, or what have you. Speaking of storage, you should know where and how long you are storing your data. And the reason I say this is that a lot of enterprise systems end up sending copies of data to different locations as they're processed by different downstream applications. I think my favorite has been one customer who was sending the same piece of data to 5 different unique parts of their whole architecture, which were each worked on by 5 different teams. And it was the exact same piece of data, but each of these 5 different teams had a different policy on data retention, and they didn't know that the other data existed. But it's the same company, and instead of being charged for storing the data once, they're being charged for it 5 times because the right hand wasn't talking to the left hand, wasn't talking, et cetera. So just keep track of what you're actually, where you're putting your data, what is the data retention policies in place, how long do you need to keep your data around for the different industries that you're in, and make sure that if you can delete data because its use is over, clean it up. It's fine. You don't need to store everything forever and ever unless you're in an industry that gets audited occasionally, in which case follow what that industry dictates. And I mentioned gateways, but really aggregate at the edge is a good way of going, because you could be dealing with individual data packets one at a time, and if each of those data packets is relatively small, what you end up having to do is build a back end that has to account for a whole lot of very little data packets, which when you're dealing with per item computes, that can put extra complexity into your data processing pipeline that is otherwise avoidable. So if you aggregate at the edge, not only can you filter out some data that might be repeats, but you can also do some local analytics to catch some things earlier and avoid having that that latency from a round trip connection to the cloud. But it also just makes everything a lot cleaner as well if you can aggregate at the edge. I also have data analysis tips and tricks. So these are different from management because it's not about like what do you do with the data, it's how do you use it. And that's the first one. Know what you're doing with your data. A couple of customers, especially early in their IoT journeys, say things like, oh, well, we don't know what we're going to do with it, but we're going to keep it in storage until later until we figure it out. And ultimately what happens is that they just discard the data up front because they really didn't know what they were trying to accomplish here. They're just like, well, we'll just keep it in this warehouse for now, and then figure out what to do with it later, which never happens because you're always producing more and more data. Now, what this might mean is that you have to hire a data scientist or perhaps train one in-house, and that's okay. This is a data scientist's job. A good data scientist is worth their weight in gold. Highly recommend getting a data scientist if you have a need for one, and have a lot of data that you know contains insights but have no idea how to extract those insights from it. This is what a data scientist does. Like that customer with a terabyte of data, just know how much data you're ingressing, because oftentimes that number can be a little surprising. If you just take the number of devices times the average message size times the message send rate, multiply those three numbers together, and now you know how much data you're sending to the cloud. If this number is surprisingly large, then you might need to adjust your send rate accordingly. If that number is surprisingly small, then you can consider, okay, well, am I actually collecting all the data I think I am, or am I able to get the insights that I want with much less data than I'd initially just thought I would need, which, again, is completely okay. You'll also need to make data ownership clear. For very complex IoT solutions, or rather complex IoT solutions, oftentimes there are multiple parties involved who have some stake in what the data is, especially for complex devices, which are made up of kind of smaller devices. You can think of it as like cars are, you have one car as the thing, and then you've got a lot of smaller devices in that car, like you've got the engine manufacturer and the transmission manufacturer, and all of them care about the data that's coming off of the device or off of the thing. Just make sure that everyone is aware of what the data ownership rights are like, and how, if that can ever be rescinded for whatever reason, or how long those rights last. Make sure everyone's on the same page, and especially when it goes back to how long you're storing the data for. And finally, be prepared to iterate. You're probably not going to get it right the first time, and that's okay. And that's just because you have to try something and you learn from it, and you try again and you learn a little more. And this is how science and engineering works, is you iterate and then you at last have a good solution. Same with agile computing, is you try something a couple times and you learn from every iteration, and you make it better every single time. So now let's talk about devices. Some of you who have played around with Raspberry Pis on your own might have wondered why I didn't start here. And that's because when you start talking about an IoT solution, oftentimes devices are not at the forefront of these conversations. It's all about what are we trying to do? Again, going back to those business objectives. And there are a couple of things to consider when you're building an IoT solution. And first and foremost is, do you have that device selected for you ahead of time? And that could be the different, in industry we call that greenfield devices, which are the new devices, versus brownfield devices, which are the old devices. And brownfield devices are already in the field. Oftentimes they've been there for quite a while. They're using some sort of legacy protocol, legacy software, maybe a legacy language, and there's already a lot of capital invested in the hardware itself. Now, the grass isn't always greener with greenfield devices, because when you're deciding to build a new IoT solution, you have to make a whole lot of choices when you're building this new device that has already been made for you when you have an existing device that you have to work with, such as what language are you going to use, what operating system are you going to use, what networking protocol are you going to use, what form factor, how many USB ports, are you going to have any external ports, et cetera, et cetera. And keep in mind that when you're building a greenfield device, today's greenfield device is tomorrow's brownfield device. So make sure you take into account the entire life cycle of the device, from initial creation through life cycle maintenance through end of life for that device when you're designing something new, so that a couple years down the line you don't wish you had a time machine, so you could go back in time and smack your old self upside the head and say, what were you thinking when you built this device? Don't you know that XYZ protocol would stop being used, or what have you? So just keep in mind that there's more involved with devices than just, am I getting a new device, or do I have to retrofit an old device? Keep in mind the entire device lifecycle. Again, I've got a set of tips and tricks for devices themselves. And first and foremost is to know that device lifecycle. It starts, again, with planning your entire solution. What are you trying to get out of your IoT solution? Are you managing traffic in a city? Are you managing a production line? And what will you have to do with those devices throughout the day, or throughout the life cycle of that solution? So for example, with a smart traffic light, you have to consider, how are you going to maintain this light if it goes down? Are you going to have to stop traffic and close an intersection in the middle of the day? Or will you be able to have access to this traffic light outside and not disrupt the flow of traffic? Or will you have to always do maintenance on this device during the midnight hours of the night to make sure that there are the fewest number of cars that are impacted? Upgrading firmware can be a pain in the ass. I recommend doing it as infrequently as you can get away with. And when I say this, I don't mean don't patch your software. By all means, patch your devices. Just know that it's much more difficult when you're dealing with IoT solutions than it is when you're dealing with managed PCs, where you can just push down an update through Intune or SCCM or whatever software you're using. When you're dealing with actual devices, these devices might be installed in a physically hard to get to position, like mounted on a traffic light, or buried deep in a mine shaft because we're monitoring mining operations, or put on an oil pump. Know that you have to have a path for upgrading the firmware, but know that connectivity might be spotty. These devices need to know when they can actually update their own firmware. They can't just update it whenever, because if you have a connected vehicle that's going 60 down the highway, you don't want it to reboot at that time and be the reason for a 20-car pileup on I-90. So keep that in mind. Upgrading firmware is definitely a part of the device lifecycle, and definitely a part that needs to be handled with care and planned for before you actually deploy your devices. Now, we talk about device telemetry a lot as the device measuring its surroundings. What temperature is it? What's the motor vibration? Is the door open or closed? But we also need to take into account the device health. It's the health of the device itself. And that's because there are a lot of things that can play a part of the device health, such as, is it physically in a good condition? Through, can I measure whether or not my device has been compromised by measuring the RAM usage of my device? To what's the battery level of the device itself. So knowing the health of the physical device, you can not only predict some of the maintenance qualities, as well as detect security threats before they actually get picked up by your backend. And there's more to devices than just hardware. And this is a cute way of saying about a second slide on device tips and tricks, because there's a lot going on with devices. And first is that time syncing is hard. This is one of those problems that you don't really think is difficult if you're dealing with an on-prem architecture or something that's all using the same clock. But as soon as you start having asynchronous device messages being sent, you start dealing with some time syncing issues, because you have to think about, how is your device being time-stamped? Are we stamping the time on the device when that message is created? Is the device stamping the time on the message when it actually gets sent to the cloud? Are we stamping the time on the device when the message gets received to the cloud, or when it stores it in an intermediate service? And so time syncing is a very difficult problem. So keep this in mind, especially if you're dealing with something that has very time-sensitive aspects. There are many ways of getting around time syncing. There are definitely solutions for it. Just be aware that time syncing is a problem you might encounter. If you're not expecting it, it can catch you off guard. You should also know the networking policy. I've been on a number of support calls where the issue is that there's a certain firewall port that wasn't opened, or you're reading messages off a certain, like one port when you're expecting to use another port because you're using a different networking protocol than was expected. So just know what's going on with your network. Don't poke holes in your firewall unless you really have to. Again, gateway devices are really great when you're dealing with difficult networking policies, because they provide kind of a safe way of collecting data from a lot of devices that you really don't want to open up to the general network. Devices and services are not the only thing with life cycles. Think about the credentials of the device. If you're using certificates, and I really hope you are, because they're more secure than just using pure password, know that certificates have life cycles too. You really don't want your certificate to have an expiry time that's many, many decades from now, because you want to have the ability to roll the cert in case the worst possible thing happens and your private key gets exposed. So keep this in mind when you're building out your system. Have a way of rolling certificates, because this will help keep your solution secure and make your overall solution just that much more secure. And then finally, be prepared to add compatibility layers. Brownfield devices have compatibility that is required from protocols to just pure app compat itself, depending on the operating system and the software running on those machines. Again, gateways are really great for adding layers of compatibility, because they're built with this in mind. So the Azure IoT Edge gateway software has been created with kind of a module structure in mind. So you can add different modules depending on which layers of compatibility you have to add to your solution. So I'm going to end with something that I like to tell myself is, don't be data dumb. When you're thinking about IoT, think about it holistically. Think about what is the business problem we're trying to solve. What are the different architecture considerations to take into account, from how am I using my data to how am I going to scale my architecture without risking bringing down any of my services because my Kickstarter went viral and it's too big of a success and suddenly all my servers go down, to what type of devices and making wise device choices. So know what you're designing for, question everything, and think big. I'll now take some questions. If you have some questions on IoT architecture, there's some mics up in the middle. Just line up and ask, or if you don't want to get up or it's hard to get up, just raise your hand, and I will repeat the question so everyone can hear. Anyone? I work on the services, so ask away.
That have special sort of hardware, and
yeah.
We could probably fetch some data out of them. They're unlikely to replace them in a hurry. I understand there's a new edge gateway. You talked about hub sort of like not having a pinch point or
a bottleneck.
Yeah, a bottleneck. Tell me a little bit more about the edge gateway, and then whether you have any scalability issues around that you can think of.
Yeah, so when you're using a gateway, just in general, when you're using a gateway device, one of the things to think about is how, what are the specifications of that device itself, like how much RAM does it have, how much storage does it have, because that will take into account what sorts of bottlenecks you're likely to run into when you're dealing with a gateway. Now, the IoT Edge is our solution for the software to enable an edge gateway. And that's built with a series of models where you can route messages from one module to another. So if you need to translate from an older protocol into a newer protocol and then run that data through, maybe decrypt the data or encrypt the data, and run it through machine learning and do some other processing before sending it to the cloud, you can easily do that by just building it out in that modular architecture and saying, okay, I've got the Modbus piece and the ML piece and an extra processing piece and finally an encryption piece before we send it up, just for added security. So there's a talk yesterday. This is the one in the middle of the Wednesday, or the top of the Wednesday session, that should be going online tomorrow, I believe, would be within the 48 hours, or if not then probably next week, if you want to see a whole 45-minute talk that dives deeper into what we're offering with IoT Edge. Yeah.
So you mentioned the client-side architecture in a very general way. What I've noticed is that I'm seeing different patterns. You mentioned, for example, aggregation, times when you only want to know when a change occurs. So there are different kinds of patterns that are there. Is there any resources that you could point to that would specifically identify those patterns as opposed to, I kind of feel like I'm reinventing the wheel, that there's nothing special about what I'm doing, but are there any resources?
Yeah, so if you go to docs.microsoft.com and go to the IoT Hub documentation, we have some patterns specifically around device management, where there are a lot of different patterns of how in general can you update the firmware on a device? Because that should be a really easy problem of how do I update firmware? Oh, you just push it down. But when you're dealing with unique hardware itself, or maybe a custom operating system, it gets a lot more tricky than that. So we have patterns around how to update firmware, how to reboot devices, et cetera. I'm happy to talk to you afterwards if you've got more specific questions on the patterns of device usage and just overall IoT. Yeah.
So one of them ties into your pricing model, for example, is based on the number of packets. And then you have a number, max packet size.
Yeah.
And so then we basically kind of have this idea of basically preparing our data to send up matching as close as possible to that packet size to minimize our cost, of course.
Yeah.
So I was just it doesn't feel, they seem like very basic ideas that probably everyone else is also doing, and I was just, you know.
Yeah. So kind of the overall question is, how do you architect for dealing with packet size, especially when billing is involved? And this kind of goes back to, you know, batch your messages before you send them, because not only are you getting, you can pack the most into the packet size of what you're sending, but it also reduces the number of connections that each device has to make. And as far as the IoT Hub services is concerned, what we do is basically to protect the service from what would otherwise look at like DDoS attacks, we throttle, for example, on the number of connections, as well as like the total number of messages sent every day. So when you aggregate the data like at the edge and then send it up as a batch, what you're doing is basically being a good citizen with respect to the service by not, you know, looking like you're DDoSing us, because it's, from the services point of view, there's no difference between, you know, suddenly you hit a spike in usage because it's midnight and all your devices have been told to phone home at midnight, and a concerted DDoS attack by a malicious actor, because both of them look like this in our usage curves. And we go, oh no, we're getting DDoSed. And then we get a customer who's like, why aren't you allowing my spikes to go through, blah, blah, blah. And we're like, oh, we're sorry, we didn't know that you were actually sending that much data on purpose. We thought that there was a problem involved. So throttling can be a tricky subject. I could do another hour-long talk on how throttling works. Yeah.
Hi, we're currently using event hubs, but not IoT hubs, so I'm familiar with the extra device management features you get. But other than that, are they identical to event hubs in terms of scalability and performance? And that's the first part of the question. The second part is there any documentation you can point us to that will help us migrate from event hubs to IoT hubs for devices that are currently talking to event hubs? Is it easy to migrate right to IoT hubs from that?
Yeah, so one of the primary differences between IoT Hub and Event Hub, so just so you know, both IoT Hub and Event Hub deal with very high scales of throughput. Event Hub, at least as of a couple years ago, throttled the number of connections and limited it at, I think, 4,000 or 5,000. I think they've since moved to billing per extra connection. And really, Event Hubs is built to act as a big data buffer in enterprise integration scenarios, where you've got one application that needs to talk to another application, and you don't necessarily need this concept of a per-device unique ID, which IoT Hub was built with. With IoT Hub, we said, okay, we're learning from Event Hubs and how Event Hubs is being used, but we know with IoT, you want to have per-device revocable access, which is just a general industry best practice when you're dealing with IoT devices, because if one single device goes rogue, you don't want to have to risk polluting the rest of your downstream data processing pipeline. You want to just say, okay, well, this one device is acting anomalously. We're going to just shut down access to it until we can debug the issue and then turn it back on. Event Hubs does not really allow that, because they have a limited number of connections that you can establish and a limited number of connection strings that you can then put on your devices. So if you're putting the same connection string on all your devices, please don't. There's a hack a couple of years ago called Mirai, where a bunch of different IoT devices like routers, et cetera, all use the same default admin password, and they got massively hacked, and it caused DDoSing of a good portion of DNS. So just as a security best practice, just like please have per-device revocable access. So that's one of the main points of difference between Event Hubs and IoT Hubs, is that concept of a per-device unique identity. And from that stems a device management functionality, which we've added into IoT Hubs to allow kind of bidirectional communication between those devices and the cloud, where not only are devices sending massive amounts of telemetry, but we can also send communication back to those devices via IoT Hub, either through a cloud-to-device message queue or asynchronously via direct methods, which are very useful when you need to do something on the device right now, but only if the device is online and capable of receiving these messages. You can also do more sophisticated device management through IoT Hub with the device twin, such as updating the firmware via the desired properties, et cetera, et cetera. We can talk more offline if you want like the full list. But device management's a big one. We recently announced about 3 weeks ago a new service for IoT Hub device provisioning, creatively called the IoT Hub Device Provisioning Service. And what that does is enables bootstrapping of IoT devices to connect to IoT Hub to make that unique per-device identity between the device and the cloud a lot more automated and a lot less painful, because security it's a journey, not a destination, as one of my coworkers likes to put it. And so being able to establish that secure root of trust at the time the device first boots up, rather than some point down the line where there's some other issues, is something we now have that works with IoT Hub, but not Event Hub, just because the use cases for the two services are quite different. I'm sure that there are more that I am missing. Message routing is another one in IoT Hub, where IoT Hub has a built-in message dispatcher, so you don't have to write your own after the fact. So you can say any device that matches this, or any message that matches this pattern, be it with properties or the message body, is then sent on to another service for further processing. And that's a feature of IoT Hub. Yeah.
You want to go ahead? No, I want to go on.
Okay. So I do a lot of machine learning stuff. One of the common problems we encounter is we need to create custom sensors every time for the customer, which means a lot of Raspberry Pi hacking stuff together.
Yeah.
Is there, a suite of recommendations that Microsoft has when it comes to like, hey, you need to get these 37 features onto a sensor board, this is the sort of board you should use?
Yeah, so we offer something that I think is similar to what you're asking for, but with the caveat that every IoT solution is a little different. So what you think is like, oh yeah, just general sensor recommendations is somebody else's set of like, I don't understand why this is relevant to me. But if you go to, I think it's catalog.azureIoTsuite.com, we have the Azure device catalog that contains devices that have been certified to work with Azure IoT. Yeah. I guess I'll leave this up.
Just kind of following up. When we talk about two different things, first of all, the update of the operating system on the IoT device or whatever, firmware, and then we talk about the actual program, and we talk about what patterns there are for, say, without actually going to the devices, going ahead and updating, making sure that those operating systems or firmware are patched, and then also that our custom program, IoT application, is able to also update.
Yeah. So one of the nice patterns that I like to recommend, especially if we're just monitoring, we call it like making sure the device is in compliance, making sure it's running the right versions of the different types of software, and being able to tell when a device is out of compliance. And for this, we recommend you use the device twins desired properties and reported properties. And what this is just you state up there what you want the device to be at, but the device needs to know how to process this information. So for example, if you want the device to be in firmware version 1.2.3, you need to also tell the device where to go in order to get the latest version of the firmware. And so what happens is the device will occasionally pull down the desired properties and it'll say, oh, I'm different. Therefore, I need to go take an action. And my action, because I'm version 1.2.2, is I'm going to go to the URL that's also specified and then update myself, assuming the device knows how to update itself, which itself gets into the type of hardware you're using. So once that happens and it successfully updates, then it now has a new reported property of now being firmware version 1.2.3. But if that firmware version update fails, then you get a message then you can see that this device is out of compliance because it's running the wrong firmware version. And you do queries across the device twin to say, how many devices do not have firmware version 1.2.3? Give me a list of those so I can go and create tickets to send somebody out to update them manually, for example. Yeah, so basically, is your question, when you're talking about the application state, is that similar? Okay, so the question for everyone is, they want to avoid having a special service that will deal with updating the application itself that's running the IoT solution. So for that, I think you can follow a very similar pattern where you just tell the device you will have app version 1.2.3, the new version is 1.2.4, go here to get the new one and then apply it. Yeah, and depending on the operating system you're using, some of this can be taken care of by the OS itself. So for example, my team worked with the Windows IoT team to help develop their package for Windows 10 IoT that deals with device management and firmware updates. So they built a lot of that into the OS itself. Docker. Docker will be more, I invite you to also see the IoT Edge talk that was yesterday, because they use Docker containers for that. Cool. Any other questions? Yeah.
So, missed the IoT Edge presentation. Did they talk about Dockerizing historians?
I don't remember offhand.
No?
I think
Okay.
they might have with time series insights, but I don't recall offhand. I wasn't, yeah. So we're almost out of time. Please evaluate the session because folks are keeping track. And if you have any other questions, you can stick around and ask me one-on-one, or you can tweet me on Twitter at nbirdie or hashtag Azure IoT tips and tricks, and I'll be watching that for other questions. Thanks so much.